Minute ventilation, or V dot E. The dot over the V stands for a rate, so it's a rate of flow, in this case, rate of airflow. The definition for minute ventilation is the volume of air inhaled or exhaled per minute. So the rate of flow in the units are milliliters per minute or liters per minute. Minute ventilation only depends on two factors, and that is tidal volume and breathing frequency. So the equation that you should know is minute ventilation equals tidal volume times breathing frequency. Now, what happens with minute ventilation during one acute exercise session? Well, with an increase in exercise intensity, you will see that minute ventilation increases linearly up to a certain point. After this point, you may see an even greater increase in minute ventilation, and that point is called the ventilatory threshold. I'm going to draw a graph right here. On the y-axis, we're going to have minute ventilation, VE. And on the bottom, we're going to look at work rate, or the exercise intensity. So with an increase in exercise intensity, an increase in work rate, we would see that minute ventilation also increases linearly up to a certain point, at which you would see a little break point and then another increase in minute ventilation, all the way up to the max. So here, let's say this is maximum exercise intensity. And over here we would have rest. With endurance training, or in elite endurance athletes, you would see that they have a lower VE at the same submaximal workloads after training, which would mean that your respiratory system has become more efficient in getting oxygen to the muscles, and we would see a higher maximal ventilation. So here we would see that at the lower work rates, minute ventilation would be less. And then again, we would see a little break point, and then we would see an even greater increase in ventilation. So with training, in red here we have training. With exercise endurance training, we would see a greater ventilatory threshold, as well as a greater maximum minute ventilation. Tidal volume, or VT, notice there's no dot over the V, so in this case, the V is a volume, not a rate of flow. Tidal volume, by definition, is the volume of air that is inhaled or exhaled in one breath. Units is in milliliters or in liters. What happens during acute exercise, or during one bout of exercise? Tidal volume increases, of course, and it increases linearly with the increasing exercise intensity until about 60% of vital capacity, and then it plateaus. On a graph, I have here tidal volume on the y-axis and work rate on the x-axis. So with an increase in exercise intensity, an increase in work rate, I would see an increase in tidal volume, up to 60% of vital capacity, and then I would see a plateau and no further increase in tidal volume. Also, with this increase in tidal volume, it takes up both inspiratory and expiratory reserve volume. So let's take a look at what that looks like. Looking at lung volumes here. At rest, during normal rested breathing, we'll be breathing somewhere around here. In and out, and in and out, and in and out. If I were to ask you to take a big breath in, you would breathe in all the way up here. And then I'd ask you to blow out as much air as you can, and you go all the way down here. And then I'm asking you to breathe normally again, and you would return back to your normal breathing pattern right here. So what we have here at the beginning, the tidal volume, so inspiratory and expiratory, that's your tidal volume right here. At the end of the maximal inhalation, all the way up here, now you're at total lung capacity. When you breathe out all the air that you can, you are now down here, what's called the residual volume. And then you're returning back to normal tidal volume here at the end. Now, between total lung capacity and residual volume is the vital capacity. So here, this is the vital capacity. Between total lung capacity and the tidal volume, this area right here is the inspiratory reserve volume. And from the bottom of the tidal volume and the residual volume is the expiratory reserve volume. Now let's see what happens to tidal volume when you start exercising. When you start exercising, your tidal volume will keep increasing and increasing and increasing, taking up more of the expiratory reserve volume and the inspiratory reserve volume as well. And you're getting closer to total lung capacity and closer to residual volume. Normally, we stay under about 60% of vital capacity. And that is because the work of breathing gets much more difficult at the higher lung volumes. So imagine you breathing in all the way to total lung capacity and out all the way to residual volume. That takes a lot of effort, especially at the higher lung volumes. So because of that work of breathing being so high, our respiratory system cuts us off really at about 60% of vital capacity. So that's why you also see that plateau of tidal volume with increasing exercise intensity. With endurance training or in elite athletes, we would see that they can increase the tidal volume just a little bit higher, getting closer to that total lung capacity, which means that we can take bigger breaths, and our VE, our minute ventilation, therefore, is also increased. So changes with endurance training, a higher maximal tidal volume in trained versus the untrained individuals. The breathing frequency is easily defined as the number of breaths per minute. So the units is breaths per minute. What happens during acute exercise? Obviously, breathing frequency increases, and it does so linearly with increasing exercise intensity. And it doesn't really plateau, it just keeps increasing and increasing until you reach your max intensity of exercise. The increase in breathing frequency reduces both inspiratory and expiratory time, but there is a slightly greater reduction in expiratory time. So on the graph showing work rate on the x-axis and breathing frequency on the y-axis, we would just see a straight line going up from rest to maximal exercise. Changes that occur in breathing frequency with endurance training is that you would see a higher maximal breathing frequency in the trained versus the untrained state. So you would see something like this, a little bit higher maximal breathing frequency at the maximal level. So let's put this all back together. For minute ventilation, remember the equation is tidal volume times breathing frequency. So at rest, a normal tidal volume is about half a liter. A normal breathing frequency is about 12 breaths per minute. So 0.5 times 12, we get a minute ventilation of 6 liters per minute. Now during exercise, let's say moderate exercise, tidal volume has increased to about 2 liters per breath. Breathing frequency has increased to 30 breaths per minute. And now we have a minute ventilation of 60 liters a minute, a 10-fold increase from resting conditions. Let's take it one step further during intense exercise, where tidal volume can go up to 3 liters per breath, breathing frequency of 40 breaths per minute. And now you see a minute ventilation is up to 120 liters a minute. That's 20 times the resting condition. So we have a large respiratory response during exercise. Now, what happens during exercise training, endurance exercise training? We said that all of these variables are increased. Tidal volume is increased at max, breathing frequency at max is increased, so it follows that minute ventilation is also increased. But there are no actual structural changes that occur in the lung due to training. But the improvements that we see, or the higher ventilation that we see, is mainly due to efficiency of the respiratory system and better trained or stronger respiratory muscles. So what we could see in the endurance trained individual is a tidal volume of 3.5 liters per breath, 45 breaths per minute, and a minute ventilation of over 150 liters per minute.